Hi, welcome to Finite Pi Videos. This is DC here. This is the continuation of my video on ICODE SLIX2. In the last video, we have seen some of the features of SLIX2, and we also now know that the SLIX2 is backward compatible with the SLI and SLIX. So everything these two tags has is also present in SLIX2. And we also seen SLIX has got some interesting features, and in this video and probably the next one I'm going to show you all the features working on SLIX2. By the end of the videos you'll be very good hands-on with SLIX2. So you can see I have connected my Arduino and the PN5180 board. I've got a brand new SLIX2 tag, and the software version is 2.5. I would like to mention something about this software. So the SLIX2, it's still in the alpha version. So this could mean I'm sure it works, whatever the screen says it works, but there could be something that's missing from the screen, which will be fixed in the which will appear automatically in the release, probably in the version 2.5, 2.6. Now I'm going to connect. We have seen this couple of times. You're going to set the RF on, activate, and the software has detected that it is the ICODE SLIX2. Now this has got so many features, and my advice is to go in the order in which I'm showing in this video. So the first thing is, let us find out how the software detected it is ICODE SLIX2. So if you go to the system, the first thing is I'm going to hit this get. Now this is a standard IS-1569 operation. This will return you the UID plus the number of blocks and the block size. And we know that the third byte, this tells you it's an ICODE SLIX tag. However, we have seen this in the documentation. If you remember, the bit 36 and bit 37, so when you decode, it tells you that it is a ICODE SLIX2 tag. That's it. Now if I go and hit the read, now this will read all the 80 blocks. This would take some time. Okay, now we also seen that out of these 80 blocks, the last block, this is the counter block. Now you have to keep in mind, this is a counter. There is a counter present in this SLIX2. We're going to see how to use this counter in the later part of my video. Now the next thing you're going to do is go to the NXP system tag and hit this button, get. Now this is something very interesting and which is required for the software development. It has got so much information in there. So if you look at the commands going on, now this is the command called get NXP system information. We have seen this in my last videos. We just went through this, and we know this is a custom command. Obviously this will carry the manufacturer code, NXP manufacturer 04. Now this command returns you a lot of data here. Now it returns what exactly is present in this tag. So I'm going to go through at least once. I'm going to go through this one by one, so that you at least covered it in theory. Now we know that these 80 blocks of memory can be divided into two pages, the L page and H page. Look at this. What the first 4 bit says is, this tells about, is any of these pages password protected. This is a brand new tag and nothing is protected. Every byte is readable and every byte is writable. You can prove it. Just go and write something into block. These are the standard write commands, which you have seen this right from the SLI tag. If I go and hit W, it writes. So if you go and say read, reads, and you can also lock, which I don't want to do now. So if the pages were locked, read or write lock, then you will see this status set to yes. Now the status tells what is the current condition of these features. Now all the locks, there is no read and write password for both L and H page. In fact, you have to keep this in mind, the brand new tag has got only one page. Now that's what this top bit says. So this address tells you where the memory is divided into two. Right now it is 0. So everything, okay, it's now everything from 0 and down belongs to H page. Everything from that cutting address and above belong to L page. As simple as that. Okay. Say for example, if this were number 10, I can't enter that. Sorry, this is just a read only thing. If this the page protection address, okay, it looks pretty is the way you read this is different from the way I'm trying to explain. I'm trying to put in simple words. Now this is going to tell me from which address onwards you're going to split the memory. If this were set to number 10, everything from 10 and below belongs to page H. Everything above 10 belongs to page L. Now the next thing says, it tells you about whether the AFI, EAS and DSFID are locked or not. Now this is a brand new tag. We have seen in the previous in the SLIX video, AFI can be locked, EAS can be locked, DSFID can be locked. But in this tag, SLIX2 tag, you can retrieve, and in the tag tells you whether it is locked or not. Remember, in SLIX there's no way to find whether the AFI EAS is locked. The only way you'll come to know is by trying to write something, and if you get the error, it means it's locked. So also this tells about when I'm going to speak about this in the later part of the video, it tells whether is this dividing the memories, is it locked, is the protection, the read write protection is locked. Everything can be locked. Say for example, I can divide into, say, the dividing address can be 10, and I can have a read and write protection for the lower page, the L page, and I can keep all the higher page or the blocks in the higher page as open. So in that case, you'll have these two bits will be set to SS and this set to no, and this configuration can be changed. You can keep on changing it. But if you want to freeze, if you want to lock all these settings, and you can do that, and in that case this will be set to true. So these are the features. Say for example, this is saying user memory password supported. Yes. Okay, SLIX, the interesting bit of this is the user memory password protection. Okay, so it's nothing to do with the locked, or it's just telling whether a feature is available or not available. Is the user memory pass supported? Yes. Is the counter supported? Yes. Is the EAS ID supported? It's a new feature which is not present in SLIX tag. You can have a EAS ID just like in AFI and DSFID. You can also have EAS ID. Is EAS password supported? Yes. This is also present in SLIX. Is AFI password protected? Yes. Extended memory read, this is the inventory read command. We have seen one version of this in SLIX. So these type of commands make the inventory plus the read operation all put together into one single command. Is it possible to select EAS? We have seen how to do the inventory based on AFI or EAS, DSFI, sorry, AFI or AFI basically, okay, not anything else. You can also do the inventory based on the EFID. Is the signature supported? Yes. One of the interesting feature is every tag comes with a signature which can be used to authenticate, or we can use that to verify that it is indeed a tag manufactured by NXP, not a clone. Is there a password for read signature? No. That means I can just read the signature. You don't have to there's no password protection like password protection of this memories here. Password protection AFI. There's no password protection for read signature. Stay quiet persistent command supported. Yes, this is one of the feature, an interesting feature which I have to spend probably now a separate video on that. The privacy mode, I mentioned briefly about the privacy mode. It supports privacy mode. It supports the destroy command, and additional 32-bit feature flags are transmitted. No, so I'm still not sure where this is available. Looks like there is going to have probably more tags in the future, okay, where some of these features could be set to no, and some of these can be S as well. So that's what my good guess is. Okay, that's all about this feature. So revise. I'm going to just recap what we did so far. So there is a command called get a next base system information command. Send this byte sequence. So you have to be careful with the request command. So here it's a standard request flag, which is set to the data is set to high, and this is a custom command, and this returns you here. So this returns you a lot of information here, and the data sheet tells you how to decode this information. It's just you have to access every individual bit has got information about whether something is present or not present. So after that you have to look for the signature. So if you type this choose this ICODE SLIX2 tab, on the top is signature. I'm going to clear the commands, go and hit the read signature, and this is a 32-byte signature present in the tag. Now most often we can use this to do the online verification, or if you got a closed system, probably you can save this along with the UID in your database, and make sure that you verify both. And you just have to best way to think about that is there is a 32-bit byte of information, and you just have to decide how to use it. Now there's nothing more to say about this serial signature, because we have seen this signature in NTAG 213 or ultralight EV1. It's the same feature available in ICODE SLIX2. So the most important thing about this, as I mentioned before, is a read and a write password. Now I can read without any password. Now there are altogether 5 passwords. I'm going to go through this read and write. Okay, now let's give it a try. I'm going to first set the right password for everything, everything that is all the from 0 to 78 blocks. I'm going to have a right password. The way you do that is the same, and also we just go through quickly. For a brand new tag, the read password is 0, the write password is 0, and the EAS AFA password is 0, and the default password for privacy and destroy is 0f000. Okay, so it's exactly the same what we did in SLIX. In order to send the password to the tag, we first get the random number, and that random number is odd with this. This is the odd random number. Random number odd with the password. Now this is the read password. Okay, it's all under section password. When you bitwise XOR, you get the same thing because it's all zeros. Set this. Now this is a very common thing we do. In order to set the password, you must be in the address mode or select mode. I'm going to choose address mode. Now set. Now password is fine. I'm able to read it. Probably now we wanted to do the right one. Sorry, I'm going to set the right password. Now once we have authenticated with the default password, next is I'm going to change it to say for example just 1 to keep it simple. 1. Okay, probably I'm going to make this as a 2 so that I can make 1 as a read password. Now as soon as you change this number, the software calculates the XORed password. So again, it's very simple. Expand this 16-bit, this is 32-bit, XOR twice. First from 0 to the lower 16 bits XORed with that, and the upper 16 bits XORed with that. Okay, so I'm going to write. Now write is okay. Again, we have seen these commands before. The only difference here is probably somewhere here, say probably in 0 1, I think. So this tells it's right password we are changing. Again, datasheet tells you exactly what should be the byte format. So in this tag, as soon as the right password is set, it immediately become, sorry, I was wrong there. Okay, so we have just changed the password. Okay, we still haven't okay done any protection. Okay, we have just set the password. So let's put it again. Okay, so what we did just now is we have changed the default password to 2. I'm also going to change the default password of read to 1. Write it. Okay, now we still haven't told the tag that we need to protect this thing. We haven't said that. Now I can still read. Go and hit this read. I can still read everything without any authentication. Probably the best way to do that is now close this thing, take out this tag, bring it back, activate, get the system information in order to retrieve the number of blocks, hit this read command. So nothing is protected yet. So what we have done so far is just change the password. Now the next thing is go underneath this. There is something called password protection. I'm not going to do the paging. Okay, I'm just using set it to default. What I'm going to do is I'm going to set now. Okay, just set all. Okay, I'm just going to set the right password for both page L and page H. I'm going to protect this entire memory with the right password. Now if I hit right here, okay, so something is missing here. Now the reason why you got an error is, looks like we need to get the data sheet. Okay, I know what the problem here is. Before you can use this operation, you have to first authenticate with the passwords. Now I'm going to, you have to authenticate with both read and write password. Now I know this password is 1 set. Oh, come on. Okay, address set, that's it. So in order to make any changes to the configuration, you have to first authenticate to set. Okay, so now the system knows I know the password. I'm going to tell the system I want to protect it. I'm going to protect both page L and page H with the right password. I still want to do a read without any password protection. Now the start page H is still 0. Now literally there is no page L. Okay, so there's nothing above 0. Okay, everything belongs to page H. I'm going to write. Now the page is protected. Okay, if you go and hit the get system information, look at that. Now here you can see that it says page L is write protected and page H is write protected, and there's nothing after that. We still haven't logged this configuration. Okay, so if I try to write something now, it is because I already authenticated. I'm going to take this tag out. Activate, read, get the system information, get the read. Okay, I'm going to write without authentication, say 05 05 05 05. I'm going to write, clear the command. So I'm going to write. Now we got a write failure. In fact, there is no response from the tag. If you try to read, we are able to read all right. We got back the old value, but we lost this what we tried to modify. So the write is unsuccessful because now it is write protected. Read the configuration or feature settings here. So the first thing you do is authenticate with the right password. Get the password is 2. You got a new exert password and say set address. You have to check the address flag, sorry, and set. Now the right password is sent to the tag. You try to write now, right? Now the write is successful. So what we just saw is with the right password, with the right protection, you cannot write without first authenticating with the tag. It's a very nice feature to have. We don't want a system where anybody can write to your tag. So this is something a feature which is present in this tag. So likewise, I can also do the read as well here. Now I'm going to go back here, go back to this place. So I'm going to say protect read as well. Both I'm going to read protect. Now I'm not sure whether we need to tick this. Just try, give it a try. And also keep in mind what we have got at present is we have just authenticated with the right password. And if you try to change this setting, you get an error message because you have to authenticate with both read and write set, okay, before you change the configuration. Write, yeah, write protection, read protection is okay. Go and hit this get features. You can see that. Oh, interesting. Okay, now what just happened was because the protection bits are still writable, what just happened is we removed the write protection here. So what you have to do is both set this and write again, and if you go and hit now we got both the read and the write password protected. It protects entire memory tag. Now I'm going to close. Now what we have done so far is we have protected both read and write operation. Activate. If I try to read, sorry, if I try to just before that hit this get, try to read. Now the read is still going on. Okay, yeah, so look at that, what has happened. The software says could not read all blocks. That's fine. If you look at the commands, because the software loops from 0 to 79, for every read single block command there is no response. So the software has tried from 0 up to 79. However, the 79th block is able to read. Now that proves the read and write protection does not apply for the block number 79, which is the counter block. That's an interesting thing to observe here. So we know that we can't read, it's fine. Now let us try and authenticate with the read. Set the read, sorry, so address set. Now if you try to read, you can see the LEDs are flashing here in the Arduino. Now we are able to read. So that's the read protection. So next what I'm going to do is I'm going to divide this entire memory into 2 pages, and see some of the applications are probably you can use this as a 2 application in a single tag. Maybe the half of the application, half of the memory can reserve for say student canteen, and the remaining half could be used for the transportation. You can do whatever you like. The feature here is you can partition the memory into 2 pages. The way you do that is, first of all, you must be in a position where the read and where you can change this part of the tag. In order to make changes here, you must first authenticate with both read and the write password. Set. Now this is done. What I'm going to do is I'm going to divide this probably at page number 20. 20 and below belongs to page H, and in fact the documentation refers this page as in a page H and page L. It could be the higher page and lower page. It's letter L and H. And because they're all writable, what we can do is probably the first part of the page L, I'm going to protect both read and write, and I'm going to keep this pretty open for the page H, which starts from block number 20. Let's give it a try. Okay, it's done. Now I'm going to close and start all over again. Activate, get the system data and read. Now in theory what should happen is, because the page L is protected with both read and write, okay, we should not get any data from page. Look at that. No data has come from 0 to 19, but from 20 onwards, which is the page H, we're able to read. And also I think it's good to have, probably what the software should have done is, as soon as you hit this get thing, it should probably show you update these tick boxes. Probably now I'll let the developers know that, so you'll have that feature in the next release. So I can write, go and scribble something here. Write, you are able to write. What about in order to get the first 20 pages? So get the random number, authenticate read, set it, if you hit again, it will go through again from 0 to 79. Probably the best thing the software should have done is have a section here somewhere where you can read from between two block ranges. Look at that, we are able to read. If you try to modify, so if you remember what we have done so far, to read and write there is a password for page L. We have just authenticated with read password but not write. I'm going to try to write something. You should get an error. Write error, we know that. If you look at the kind of error you get 0F. This is a custom error, and I mentioned this in my earlier videos that whether you get 0F or just 01 depends on the addressing mode. In address mode set to 1, you'll always get F, otherwise you get just 01. Okay, and so authenticate, set. Now try to write. Just clear the screen. Now try to write. We're able to write successfully. Okay, so I think I'm going to stop the video here because now in the next video I'm going to cover the remaining features. So to summarize, what I mentioned is, follow in the same sequence what I have done in this video. Activate a tag, go to NXP tab, hit this get, all the features that are available in the tag, and go back here, play with the read signature, then play with this, understand how the read and write password works first, then try with this, splitting this into 2 pages. Okay, thanks for watching.